Assalamualaikum and good afternoon everyone. So today I'm going to discuss about sp hybridization. So first we take a look at the definition, right? So we can define sp hybrid orbital as the mixing of s orbital with one p orbital. So it will form two sp hybrid orbitals. The electron pair is 2 and both electrons are arranged according to the shape of linear. Okay, and therefore the bond angle between these two hybrid orbitals is 180 degrees. Okay, alright, we take a look at the example. Alright, so the first example, so for beryllium hydride, step 1, we have to draw the Lewis structure and we have to calculate the total number of valence electrons. Right, second step, so you have to identify the class of compound. Alright, since in the Lewis structure, there are two bonding pair electron, so the class of molecule is AB2. Okay? And the shape here is linear shape. Okay, the bond angle here between the BEH bonding electron is 180. Right, so this is how you can write the explanation to describe the molecular shape. So the molecular shape of beryllium hydride is linear and with the bond angle of 180 degrees. Right, step number 3, what should we do? So we have to determine the type of hybridization. So how to determine the type of hybridization? So we have to refer back to the molecular shape. We have to count how many sigma bond and how many lone pair if any. So since in this molecule there are two sigma bond here, so therefore there are two electron pair present at the center atom. Okay, so the type of hybridization is sp hybrid orbital. Okay, and the sp hybrid orbital, it contains two electron pairs and both electron pairs are arranged according to linear shape. Right, step number 4, we have to draw the orbital diagram. We start with orbital diagram for the center, that is the ground state. So as we already know, valence electron of beryllium is 2 and both valence electron is located in 2s orbital. However, when we refer back to the structure, so beryllium hydride will form 2 sigma bond. Okay. At the ground state, so beryllium cannot form any sigma bond since the electrons are paired electron and located in 2s. Alright, so in order to form 2 sigma bond, one of the electron from 2s is promoted to 2p. Okay, so you can write the explanation like this. So at the ground state, beryllium cannot form sigma bond. Therefore, one electron is promoted, okay, from 2s to 2p orbital. Okay, and it will form new state that is referred to the excited state. So at the excited state, there is two single unpaired electrons that is located in 2s and 2p. However, at the excited state here, the electrons are unstable. So how to make stable? So both orbitals have to mix together. So mix one s2s orbital with one 2p orbital and it will form two sp hybrid orbital. Okay, so you can write the explanation like this. Mixing one 2s orbital with one 2p orbital form two sp hybrid orbital. And then there is remaining two empty 2p orbital. And this orbital, even though it's empty, you still have to draw the orbital diagram for the hybrid state. Okay. Alright, next. For the orbital diagram for the terminal is referring to the hydrogen. Okay, so hybridization only occur for the center atom. Terminal, you can write the ground state. So hydrogen will have one valence electron and it is located in 1s orbital. So now we can clearly see that the sigma bond is formed between 1s orbital overlap with sp hybrid orbital of beryllium. Okay. Alright, so you can write the explanation like this. Overlapping 1s orbital of hydrogen with sp hybrid orbital of beryllium form sigma bond. Okay, step number 5, you can draw the orbital. So we have to follow the molecular shape. Okay, molecular shape here is linear. So it's better if you will draw the sp hybrid orbital first. Okay, so first you have to draw the sp hybrid orbital. Make sure when you draw the both s hybrid orbital is in linear position. Tak ada bengkak-bengkok macam ni. The sp hybrid orbital is overlap with 1s orbital of H. So the shape for 1s is spherical shape. Right, next, at the overlapping area, so you have to draw the electron spin up and spin down. Then forget to label the sigma bond form, and then the sp hybrid orbital, 1s orbital, and lastly is okay. So we have done for this question. So now we take a look at the second question. Alright, so CH triple bond CH. So this is also known as, the name here is ethyne. Right, so the first step, what should you do? You have to start with the Lewis structure. So you have to calculate the total number of valence electron. So as you can see here, there are two central atoms present here, which refer to the carbon. As for the hydrogen, it always becomes the terminal. Okay, so now we draw the center atom. Alright, and then draw the terminal. Alright, so actually we already used 6 electron here for the bonding electron. We have balanced another 4, and then you have to place it on the center. So we already used all the electrons here. However, for the center atom here, we can see that the carbon is not octet yet. So it has 6 electron here. So we have to make sure the carbon is achieve octet. Right, so how that we can do that? So you have to place the lone pair of carbon to the bonding electron to make it triple bond. So we write it again for the Lewis structure. Finally, we will get triple bond between both carbon, like this. Right, so second step, what you can do is you have to draw the molecular shape here. In order to draw the molecular shape, you have to identify the class of compound. Right, since there are two central atoms here, so you have to identify both class of compound, but one by one. Okay, right. So let's say you want to identify the first center here. Okay, C1, label is C1. This is C2. Right. So take a look at C1 here. So we have one bonding pair, and there is triple bond here. So remember, the triple bond we count it as a one bonding pair. So one bonding pair, two bonding pair. Okay, same thing goes to carbon number 2. We have one bonding pair, two bonding pair. So therefore, both center atom has the same class of compound, which is referred to AB2. So we can conclude that the class of compound is AB2, and the shape here is linear. Alright, so actually, we already draw the actual shape for the molecular shape for ethyne during the Lewis structure. Now we want to identify the bond angle here. Okay, so the bond angle here is 180. Alright, and now you can write the explanation like this. The molecular shape of C2H2 is linear. Okay, with the bond angle of 180 degrees. Alright, step number 3. So we want to identify the type of hybridization. So how that we can identify the type of hybridization, we just take a look at the both central atoms. Okay, now we take a look at one by one for the first carbon here. The first carbon here, second carbon, first carbon here. So to identify the type of hybridization, so we have to consider only for the sigma bond, and is there any lone pair? So no lone pair at the center. So we have one sigma between carbon and hydrogen. However, for the triple bond, it consists of one sigma and 2 pi. Pi bond is not considered for the type of hybridization. So therefore, there are two sigma bonds for the first carbon. So when we refer to the second carbon, second center atom, carbon 2. So also it has the same two sigma bond. One sigma bond here and the other one here. So meaning that both carbon have the same number of bonding pair, which refer to two electron pair. So the type of hybridization is sp. Two electron pair here are arranged according to linear shape. Right, so step number 4. So you have to write the orbital diagram. First, you have to draw the ground state for carbon 1 and also carbon 2. And then we know that the center atom carbon has 4 valence electrons. Okay, so therefore at the ground state, carbon have 1 paired electron and 2 single electron. However, when you refer to the molecular structure, so we want to form 2 sigma and 2 pi bond for each of the center atom. At the ground state, for both center atom can only form 2 sigma bond because it has 2 single electrons. So therefore, one of the electron from 2s has to be promoted to 2p, okay, in order to form 2 pi bond. Right, so you can write the explanation like this. At the ground state, carbon can only form 2 sigma bonds. Therefore, one electron is promoted from 2s to 2p orbital, and it will form excited state. At the excited state, it will have all single unpaired electrons. 1, 2, 3, 4. Okay, and all this electron is unstable. So mixing one s orbital with one 2p orbital, so it will form sp hybrid orbital. 2 sp hybrid orbital. So we draw the electron at the hybrid state. Alright, next there will be balance, remaining 2 electron left at 2p orbital. Okay, so we have to draw the electron. However, we have to label it 2p pure orbital. Okay, 2p pure orbital. How that you can explain this one? Okay, right, so you can explain like this. So mixing one of 2s orbital with one sp orbital form 2 sp hybrid orbitals. Right, so now for the terminal is referring to the hydrogen. So at the ground state, hydrogen have only one valence electron that is located in 1s. How that the sigma bond is formed? Right, so the first sigma bond is formed when the overlapping of 1s orbital of hydrogen overlap with sp hybrid orbital of carbon. So this is the first sigma bond. So for the second sigma bond, it is involved the overlapping of sp hybrid orbital of carbon 1 with sp hybrid orbital of carbon 2. Okay, so form second sigma bond. Okay, now for the pi bond, So for the pi bond involve overlapping of 2p pure orbital of carbon 1 with 2p hybrid orbital of carbon 2. The second pi bond is formed when overlapping of 2p pure orbital of carbon 1 with 2p orbital of carbon 2. Okay, this is pi bond, pi bond. So, for the explanation, you can write like this. So, we take a look. Okay, so overlapping of 1s orbital of H with sp hybrid orbital of carbon. So, it will form sigma bond. And then overlapping of sp hybrid orbital of carbon 1 with sp hybrid orbital of carbon 2, so it will form sigma bond. As for the pi bond, is involved overlapping of 2p pure orbital of carbon 1 with 2p pure orbital of carbon 2. Okay, now we move to orbital overlap. Okay, so for the orbital overlap, you can use the molecular shape as the reference. So you know that sp hybrid orbital is the two sp hybrid orbital are arranged according to the shape of linear. Okay, so first you have to draw the sp hybrid orbital for the first carbon. Alright, so next you draw for the second sp hybrid orbital for the second carbon here. Next, draw at the overlapping region. Alright, the overlapping region, you have to draw spin up and spin down to show the electron that form sigma bond. Okay, and then so for each carbon here, it will overlap with one s orbital of hydrogen. Kiri kanan hydrogen. Hydrogen. Okay, which means the shape here is spherical shape. So you have to draw the spherical shape. Okay, and then don't forget to draw the arrow, spin up and spin down. And you have to label sigma bond. Alright, next for the pi bond, it involves overlapping of 2p orbital. Let's say we have 2px here of carbon 1. Okay, overlap with 2p carbon 2. So and then you have to draw break to show it's the overlapping. And at the overlapping areas ini, you have to draw spin up, spin down. Okay. So this is the first pi bond. For the second pi bond, so you can draw like this. Alright, so you have to label pi bond. Okay, and then electron spin up, spin down. Alright, next, label the rest. Okay, that's all. 2 example for sp hybrid orbital.